Hello again everybody. On this video I'll update you on two new systems that I have added to Omapeli. In the last devlog I told you that I would be beautifying the game world, and this is exactly what I have done. I have added a nicer sky system and a water system to the game. Let's have a closer look on both of these, starting from the sky. Making the sky felt a little bit difficult in the beginning. I realized that clouds behave different compared to the ground level objects. This is no surprise since they are made of tiny liquid droplets floating in the atmosphere, instead of being solid walled objects with well-defined borders. This is why I couldn't just make a 3D cloud geometry and throw it to the game. It would look too much like a solid object just floating on the sky. For Panda 3D there is the render pipeline that you can use to easily create real-time photorealistic scenes with various post-processing effects. The render pipeline would handle volumetric clouds as well, but I wanted to implement the clouds on my own, so I could have the most artistic freedom with them even if the end result would look not that realistic. After searching around for different solutions on how to make clouds, I knew that I would have to use shaders to make the clouds appear cloud-like, and that I could derive somewhat realistic clouds from the Berlin noise, which I have previously used for the terrain, for example. A 2-year-old Reddit post from Dreamhunt Studio showed how far Berlin noise could be taken with some clever shaders. Inspired by this, I started my humble clouds by making a plane above the player's head and texturing it with Berlin noise image. Pretty basic though, and not that cloudy looking at this point yet. I thought a plane would work fine, but somehow it looked like, well, a plane on top of the player's head instead of a sky. I tried increasing the size of the plane, but something was still off. Anyhow, I continued the work, that is, when I was not constantly monitoring the YouTube statistics, and I created a small Fragment Shader to displace the Berlin noise texture. This already looked quite a lot better, but the issue was that it still was just a plane above the player's head. Even before astronomy had been invented, people probably have perceived the night sky as a dome or a sphere that encapsulates our world. Following the same idea, my next step was to move away from the sky plane and create a dome that would act as a host for the day and night sky events. My initial implementation looked promising, but the clouds seemed to bend around the sky dome and not to disappear to the horizon as they usually do. I started to think about trigonometric functions, and after checking some, I realized that the tangent function would probably do the job. And look at that, it did. Finally, I had something that had the potential to look good. With some minor adjustments, like adding another Berlin texture that scrolls with a slightly different velocity, the game already had a blue sky with moving clouds. The final touches were attempting to reproduce some atmospheric scattering, especially during the sunrise and sunset, and to create a disk around the sun. And this is the outcome of all that work. The next step would be to add some stars for the night sky, but that is a story for another time. Okay, and then the second system that I have been working with is the water. I started by creating a flat plane, and for convenience I set it to follow the player in the beginning. I used Berlin noise for the texturing here again, already giving the plane this wavy looking surface. But with water, one thing I wanted to capture was reflections, so I went to check from Panda 3D's manual how to render the camera's view into a texture. And after few iterations, I started to have well-behaving, textured view of the world. Next, from the Berlin noise that represents the height of the water, I calculated the surface normals and stored their X, Y, Z components to the 3 color channels of the texture image. Then I selected a point from the camera view containing texture using these surface normals alone. The surface normals alone create a kind of a mercury pool-like effect because the reflections made this way did not take into account the camera's position relative to the calculated water fragment. So, I made a shader to calculate the camera's position relative to each fragment and then use this camera position vector and the surface normal vector to calculate the reflection vector based on the law of reflection. I tried to improve the look of the water further, but I think eventually I came up to destroy the nice reflections that I had before. For lakes and small ponds, the fragment shader calculating reflections work nicely, but I want to have later on bigger waves also in the game, so I started to experiment with a vertex shader. Here, each vertex is shifted based on a Berlin noise texture either up or down, creating a 3D wavy effect. Finally, I wrote a system that places the water tiles there where the terrain height goes below a limit and used the pandas LOD node to adjust the level of detail automatically. After sharing these results in Twitter, Lifeland suggested to use a simpler technique in which you would use scrolling textures and the Berlin noise simply to shift the reading of the camera texture. Since this would not require calculating the surface normals or the reflected vectors, it would likely be faster and lighter for the GPU. I didn't test this yet for this video, but you will hear about it in the future. Yet again, thanks for watching, and I'm keen to hear any comments you may have. I think I'll be still beautifying the game and also checking how its performance is doing. But soon I'll start with the more interesting part, that is the basic gameplay loop and the fighting systems. For those, I have planned some neat features that should make the game exciting to play. I think I could have a playable demo ready sometime by end of this year, but we'll see. Until next time, bye!